Hello everyone. So I would be likely continuing the lecture from here. So I would be talking of the section 5.5, 6 and 7 of the book. So it basically covers the knowledge-based systems for interpretation, design codes and standards as interpretive knowledge, and then a summary of the contents covered yet. So like before moving on, there are some definitions which I would like to have over here. It's like an expert system. So an expert system is basically a computer system that emulates the decision-making ability of a human expert in a restricted domain. Then the knowledge base, which contains the essential information about the problem domain, often represented as facts and rules. The inference engine is basically a kind of mechanism to derive new knowledge from the knowledge base and the information provided by the user, often based on the use of rules. And then we have a user interface, which is the interaction with end users. Okay, so a system for the interpretation of graphical descriptions. So it's basically it consists of geometric reasoning, feature recognition, and the communication between expert systems. So like in the example, it's like the layout of a house, which has geometrical blocks for various rooms as well as floors, and those rooms and floors are provided some features as well, features and labels. So it's basically like civil or architectural design people communicate with these drawings to like share their views on how the layout of a building should actually be. So it's basically the communication between expert systems. So like one more example would be a neural network. Like why a neural network? Because it like actually covers everything which I'm going to discuss forward. So like before going ahead, who all know anything about neural network? Good morning. Neural network? Nope. Nope. Yes. No. Okay. So what I am discussing here is basically an AlexNet kind of a neural network. So it was like created in 2012. Basically, it is used for extracting features and from the images, kind of like detecting objects and different classes from the images. So I think I should not go into the depth of how the model works, but it's like you can consider it as a black box. You just enter the image and you'll get the output of what the image is having. So like this is the traffic sign dataset actually. So kind of like how you train a neural network. So the neural network would try to find out these images, like these sub-images in a set of bigger images. So the results are basically like if you want a result in the label form, you will get the labels as shown in the left portion. Or if you want the result as a set of probabilities, you can like get it in the right portion where you have the top guesses and the prediction of like the probability of how accurate the prediction you made is. So now, experientially based interpretation knowledge. It's actually kind of spatial properties which have well-defined knowledge. And then we have the rules of thumb, which actually comes with experience in that domain. Like people with more experience have a certain rule of thumbs which actually simplifies things, which more or less are sometimes accurate, sometimes they are not, but yeah. And then we have idiosyncratic knowledge, which is experiential knowledge, and then the design guides for kitchen, like that. Then it's an example of the design guides for kitchen, which embodies a spatial stance for various activities, functional requirements, and recommendation for ideal relationships between the elements. So, like the figure in the right is just showing an example for that. Now it's like a GUI. So GUI basically is a graphical user interface which acts as a mode of communication between the software and the human user. So basically it consists of text or graphic windows with several modes of operation. Graphical descriptions is interpreted to produce facts about the objects and their relationships, resulting in a fact base, in the sense that basically rules and the facts and rules, collection of facts and rules. Now the system interprets and evaluates these facts using its knowledge base, like in the neural network example I've shown earlier. I didn't describe it much because we have short time. But okay, fine. The system is like in a neural network, what actually happens is we train the neural network with some images or some data. So the neural network is actually treating that data as a database or a knowledge base. So the next time we give another random data, it's more like the system is now an expert with the data set which we have provided for training it. So any other data would not like lead to good results. You can just treat it that way. So like interpreting graphical descriptions of engineering objects. So it's like the system identifies features of objects and categorizes the objects into classes. And it then interprets information displayed graphically on a screen, and then it builds a descriptive model of the design as a frame description. So on the right we have another example of the same neural network, which is like predicting which like object is there in the picture, and it's like betting on the top 5 guesses of a mite, container ship, motor scooter and a leopard. So it's basically how a system interprets the knowledge which it has and the new data which is coming to it, and analyzes it with the database and the knowledge which it has to give the desired results. So the organization of a system for interpreting and producing structures, that's another example, which provides with the user interface a graphical display, interpreter, and a semantic modeler and a frame system. This example is a hierarchy of structural objects, in the sense that a physical object is a structure, agreed. So is it a line structure or line element structure or a surface element structure? And then like we divide it into sub branches and like branch it out to the node which such that it cannot be divided further. So what exactly is simulation knowledge? Simulation knowledge actually is the knowledge which the simulator has, provided the facts and data which we have given, the constraints which we have provided it, and the operating conditions which we want that system to operate in. So a water pen is actually an example which has the heuristic knowledge about the water penetration through windows in building. It has the qualitative knowledge about the complex behavior of water in a window system. So these two things are the constraints under which we want the system to operate. So we connect the system with a display so that we can visualize it in a better manner, and then interpret the results to derive the performance of the design in terms of water penetration. So basically the knowledge base includes qualitative knowledge of the penetration process. Another example is a restaurant manager. So what actually it does is it basically optimizes, it tries to optimize the resources which it has and increases the efficiency under the constraints which we have provided, like the number of employees, the menu, and the orders which we are coming with, the orders on the table currently, and then everything else. Okay, so design codes and standards as interpretive knowledge. So, okay, so it represents a significant body of the design knowledge and are often casual and experiential. It has a formal appearance, but they rarely constitute logical monotonic systems. So now you all would be wondering why again the neural network. It's like explaining it in a simpler manner, the neural network is drawn in this way, but we all know that it doesn't work in the same way. We need to code it out, right? So it has a formal appearance, but you cannot use it as a logical block because we need to like get into every block and write the code for that. So it's just for representing and sharing the knowledge. Establishing performance specifications from design codes. It's like we have the constraints as well as the requirements, and then we translate those constraints and requirements to multiple if and then statements. So these if and then statements are then acting as the building blocks of the simulator or the program which we are trying to make. Okay. Compliance checking with design codes is basically extracting a model representing as a frame from a knowledge base made up of rules, in the sense that we have a knowledge base which is consisting of a set of rules, and we are extracting a model based on that set of rules. Like for an example, there is a room. So the room can be a bedroom or a living room or a bathroom. We haven't specified, but the rules say that it can be a bedroom or a living room or a bathroom. So the model is having 3 branches or more, like if we put in more rules. So a model facilitates the communication between an expert system and a computer aided design system, in the sense that the expert is actually trying to lay out his knowledge on a simulator or a CAD model, and from that CAD model he's trying to tell the computer that what he expects from the design. So the working of a knowledge-based interface actually is like we have a frame system as well as definitions, and then we have an interpreter which interprets those frames and definitions to create a fact base. So a database and a fact base are there. So database is the set of rules, a set of examples as well as the constraints. Fact base mostly consists of rules, which help the interpreter to interpret the frame definition, frame knowledge, in the sense that if I'm like an expert who is making a CAD model, so okay, I'll explain it in this way. Like I'm an expert and I'm making a CAD model, so my input to the computer would be my imagination or my thinking of how the CAD model is supposed to work under certain constraints, right? So I have drawn a CAD model, but the computer is still not aware of how the CAD model should work or what actually is the intention of making a CAD model. So that's where a fact base comes in. A database helps me as an expert to figure out what actually the computer needs in terms of the requirements which I need to specify for that particular CAD model to work correctly in the simulator. So the interface between an expert system and a computer-aided system is like the CAD system has its own database, which is linked to the model. Me as an expert would be like making a CAD model for that based on my own knowledge. So I have a knowledge base which is my own knowledge base, and then from my own knowledge base I design a CAD model and on the computer end and upload it on the computer. And on the computer end, the CAD simulator has its own system as well as its own database, in the sense that it has certain set of tools which are used by the CAD model, so for easier interpretation, like if I draw a line, what that line means in the CAD simulator. So like this is actually the interface between the expert system and the CAD model. And then like another example is a 2-bedroom apartment. So it's like the expert drew it on the CAD and then labeled it. But how the CAD model like interprets it depends purely on the CAD database and how the interpreter is actually working. So for summarizing, interpretation can be modeled by deduction, that is, case plus rule leads to results. The three factors which affect it are parsing has a role in interpretation in natural language. Knowledge by which we make interpretations is not always complete, in the sense that it might be incomplete, it might be corrupted, it might be inaccurate. Interpretive knowledge is not always consistent, unambiguous, and certain. So basically, evaluation is a comparison between interpretations, design codes as repositories of interpretive knowledge, interpretive knowledge for the production of design descriptions, and then using interpretive knowledge to suggest the form of artifacts or to guide the generative process. That is basically generating and testing, and then again, based on the results, trial and testing it again. Questions? Thank you.